you're looking at a couple of my old dead Tektroniix scopes. This is the 321 laying on its side with the sides taken off. And I've also got the 535A, which has got high voltage problems, which is why that high voltage area is all exposed. I'll make a separate video on that, but I'm getting, instead of what, 8,000 volts for high voltage, I'm getting about 1,000, so something in this area is not so good. This one's got a voltage problem too. So this is an AC/DC set, and it's supposed to bring in 10 volts by one of three sources, either batteries, external DC, or AC, and produce 10 volts here across that capacitor. And that's from the manual. I'm looking it up. It says that's where you should see regulated 10 volts. So let's see what we see here. They flip it on. There's a warning sign there. My 100-watt bulb is drawing a lot of current. So drawing about a little close to 3/10 of an amp, and I'm only getting 1.4 volts across that capacitor, or 1.5 instead of 10. Let's turn that off. So here, let me short out that capacitor to drain any voltage out of it. Let's check the resistance across it. See, we're getting about 7/10 of an ohm. I was getting as low as 4 or 5/10 of an ohm. So I think that capacitor is shorted, or something else in the circuit is shorted. It's changing slightly because the voltage did go up from about 1 volt to 1.7 or whatever. So I think I'll pull that thing out of the circuit and see if that solves the problem. Let's try that first. Alright, so I lifted that capacitor and I measured the capacitance. It's about 125 microfarads, which is a 100 microfarad capacitor, so pretty close. Let's go ahead and flip the power on here again and see what we get. And now we're getting, with that capacitor out of the circuit, we're getting 1 volt there still. It's still drawing too much current. The bulb is lit up. So the capacitor wasn't the problem. Strike one. Let's keep digging. I've been poking around on this thing a little bit more. I found at least one problem, one reason it's drawing too much current. One of these transistors down here, these are the power transistors that switch back and forth and create the voltages that the oscilloscope needs. Since it's normally runs on DC, you know, you need to make some higher voltages, so you have to up the voltage. So that's what these do. One of those has a direct short emitter to collector. So those are, what are they, 2N 307s, and I looked in the manual and it says there's a replacement, suggested replacement for those, which is still a germanium high power switching transistor, but I've ordered a couple of those. I found them on eBay or something somewhere. They're just poles, but hopefully they'll work. So those are coming, but I'm still getting too much of a current draw across that that fuse, even with this part of the circuit disconnected. I've disconnected that, and that connects over here. So something in here I think is still drawing too much current. So here's my notes. I'm just going through all of those resistors and measuring voltage across it and figuring out what the current is through each one, and trying to figure out where I'm drawing current. So I'll keep going on that. Hopefully get this thing going. Alright, I've been working on this 10 volt voltage regulator circuit, which is right here, and I know these two transistors, this one here and this one here, are shorted, and that Zener diode is bad, 6 volt Zener diode. So possibly this one too. I'm not sure, but I don't remember on that one. But got at least two germanium transistors, which are bad, and those things are getting kind of rare and hard to find, and replacements are expensive. So I think what I've done right now is I've hooked up my 10-volt supply, or a 10-volt supply, to the output of that, and that seems to be working. Now I had to disconnect the emitters of these shorted transistors over here, which are the what would you call those? I mean, they'll switch back and forth and create the AC that goes down to this little transformer that supplies voltages to the rest of the scope. So, it's taking the battery voltage or the rectified regulated voltage that from the AC and creating AC again. So since those are bad, if I connected these up, it would crowbar my power supply. So just more verification that those transistors are shorted. So my plan is, after replacing these, if the scope works, I'm just going to pull this part of the circuit out and put a little 3-terminal 10-volt IC regulator in there. That's less than $1 versus, I don't know what those transistors would cost, but last time I tried to buy them, they were not cheap. And I don't even know if that's the extent of it. This one could be bad. There could be other things in there that are not good. So rather than chasing that, I'm just going to punt on that and go with a modern solution. So that's the plan. If I get the scope to work with these transistors replaced, 3-terminal 10-volt regulator in there, and call it good. So these are on order. Hopefully they'll show up in a few days and I can try that out. Okay, the 2 transistors, vintage germanium switching transistors that I ordered should arrive today. So I got the old ones pulled out, and here they are. And it's cool how Tungsol, I guess, painted them Tektroniix blue before putting their product information on them. I guess that's what happened back in the day. But anyway, these are the two. One of them's bad, one's good. So I thought I'd use the multifunction tester here to test these out. And these are great little tools. I think these things are like 20 bucks or 25 or something on Amazon, and they'll pretty much test anything: transistors, resistors, capacitors, inductors. So let's hook these up and see what they say about these two. Here's the first one hooked up. Forgot if that's the good one or the bad one, but let's try the tester and see what it says. Unknown or damaged part. Okay, let's try the other one. Alright, here's the first transistor. This is the bad one. You can see it turns up as a resistor. This is the one that's shorted out. Now let's retest it. Just to show you the process here. Yep. It's just a resistor. Let's try the other one. Okay, got the other one hooked in here. Let's see what the tester says this is. Oh, look at that. It's a bipolar junction transistor, a PNP. It's got information on the HFE and all kinds of other things. So let's put these on the curve tracer down here. My old vintage 1957 Tektroniix curve tracer. Let's see what it can tell us about them. Alright, we've got those hooked up. One on the A side, that's the good one, and one on the B side, that's the bad one. So the A side here, flip the switch, and we have some nice transistor curves. Those look pretty normal. And the B side is, whoops, yeah, that's a resistor, alright. That's all it's showing. So that confirms it. It definitely This one transistor shorted and one's pretty good. So 3 different ways to test. One with an ohm meter to check out shorted junctions, one with a little multi-tester, and then this way it actually shows you the transistor curves. Now the reason I set this up is that the 2 transistors are supposed to be fairly closely matched, so when I get the transistors today in the mail, I'm going to go ahead and put them on the curve tracer and see how they compare using the AB comparison switch. Alright, I just got my 2 new transistors from eBay. Let's see if they work. Well, the first one seems to work. Now, these have the look of Chinese knockoffs. That's probably what they are, but we'll take a look at them on the curve tracer. HFE of 62. And this one's working too. HFE of 82. Okay, let's fire up the curve tracer. All right, here we go. There's one side. It's kind of a strange looking curve. There's the other one. It seems to be breaking down about 16 volts. We have collector voltage. But that one's maybe breaking down. It has a strange upwards curve on it, not real linear. But hopefully they're matched well enough to be able to work in the switching circuit. Just plug them in and give them a try. Well, I do have a display. I've got some noise coming from the switching transistors. And there's what the collector looks like. It's really bouncing around. And seems to be drawing a lot of current. You know, like that about 4 or 5 amps of current. So that's actually crowbarring my supply. So something's a little goofy with this, but at least I can tell that the CRT is good. And the electronics, I still have to look into this supply and see if maybe there's some other component in there that's causing that voltage to be a little wacky. And but we're getting there. Okay, started troubleshooting this. Why this thing, the little inverter here, or chopper, whatever you want to call that, is drawing so much current. So I'm looking at on this side. Here's the 2 transistors. That diode seems to be good, but that capacitor right there is reading open. So it's no longer a capacitor. So I've got a little, it's a, what, it's a 10 microfarad. This is a 10 at 50. That's like a 10 at 15. So I'm going to go ahead and pop that in, see if that helps. I got that new capacitor in there. You can probably hear those transistors are still singing. But they're not singing very well or on key. So you're bouncing around a lot of DC offset. And still drawing a lot of current. My power supply is still crowbarring, delivering 500, about half an amp. Okay, on a lark I just said, well, let me try putting that fuse back in and hooking up the regular AC supplied 10 volt power source and regulation. Well, we got these transistors replaced, and let's see what happens. So I've got the meter hooked up on the output of the 10 volts, and it's reading right at 10 volts here. Output. So that seems to be working. We're getting some strange flashing on the screen, so there's still something wrong. But at least this part of the voltage supply or power supply is working. So we'll flip it over and check to see if the all the voltage is going to the CRT are proper. I've gone through all of the low voltages that are listed on the schematic, and it looks like everything is there. And it's looking good. Slightly higher than what it should be, but maybe because it's running off 124 volts instead of 117. So I think now it's time to take a look at the high voltage here. So I'll have to remove the protective plate here and get my high voltage probe out, and we'll check that. Okay, so the diagram says high voltage should be 3350, 3350. And it's taken right there. And we're getting glare is what we're getting. 3600 volts, 1600. So high voltage is a check. Alright, looks like we're getting there. Definitely getting a display. I'm just feeding that off of my the output here from my 585 scope over to the input. I'm not sure what's causing that blinking. This guy's blinking here too, and the display's blinking. So I'll investigate that. But it looks like we are getting the display, and the scope is triggering, and all the voltages are correct from what I can see. Just gotta figure out what's going on here. Okay, the flashing seems to have gone away. I noticed that that's showing up, but there's the pilot light right there, and kind of that was flashing, and in connection with that there's the intensity pot and the focus pot. So I just played with both of those, swiggling them back and forth, and that seems to have gotten rid of the blinking of the display. Now that's working fine. It's not the full width of the CRT, so that's an adjustment or something, but see, it's still blinking a little bit. Maybe we'll... Unfortunately, a lot of these pots, they're pretty sealed, so you can't really get any cleaner in them. So I found I had to disassemble those before to get them clean, but maybe if I just keep wiggling that'll clean that up. But anyway, that's what it's looking like right now. I've got a nice display. Vertically it seems to be accurate. Horizontally it's not covering the whole screen yet, so that may just be an adjustment. Let me poke around so we can find that. But we're almost there on this little guy. I found an adjustment called sweep length right here on the side of the scope, and I tweaked that a little bit and got the display to go all the way across the screen. That's looking much better. I'm still playing with the intensity to try to clean that up, but it looks like it's working. So I may just call this one fixed and put the sides back on it. It probably needs to be calibrated, but I'm not really going to use this as a real scope. It's just I wanted to get it working. I don't know, maybe I'll go through and do a calibration just for fun, but looks like it's there. So let me go ahead and put the side. Well, let me leave the sides off because maybe I'll tweak a little bit. But I think I'm going to call this a wrap on the video. Got the old 321 oscilloscope from what is it, 1960, working again, and this is the battery operated set. Got a few bad caps here that had to be replaced, and then also had the little switching transistors. One of these guys was shorted, and that was preventing it from generating all its high voltage DC voltages. So looks like we're good to go. And again, this is one more oscilloscope that was going to the trash that was rescued. I really didn't plan on getting this one working, but it was a bit of a challenge. Also, when I did the original video on this and put it up as a non-repair, I got a comment from somebody, I think in some foreign country, because the language was maybe it was Danish, and he had a little sad face. So hopefully he'll be happy to see this thing up and running again. So that's it. The old 1960 Tektroniix 321 oscilloscope up and running again. Thanks for watching.